This is geometry lesson 8.8 and 8.9. We're going to be looking at circumference and area of circles, which you've done before. So this should feel pretty much like review. The new thing that we're going to add is we're going to be slicing these into pieces, and based on the degree measurement, we can figure out what's the length of just an arc on the outside, or what is the area of what's called a sector, which is kind of like a pizza slice of the circle. So we'll get to that second, but first let's just run through our review of how you find the circumference and area of circles. So for circumference, which is like the perimeter, let's make sure we remember that. Circumference is the perimeter, which is the distance around the outside. So if this was a string around the outside and then we pulled it all the way straight, how long would that be? Or if this was a distance that you could walk outside, if you walked all the way around the outside of the circle, how far would that be? Its circumference equals pi times diameter. And we know that the diameter is the distance all the way across the circle through the center. So a diameter is formed by a radius in one direction and a radius in the opposite direction being combined. So a radius is always half of a diameter. So you could always use this formula as well. I don't use this one as much. If I am given a radius, I'll just double it, which is what this formula says, right? 2 times the radius is the same thing as using the diameter. So we're going to focus mostly just on the formula with diameter in it, but you could obviously use this one as well. And then when we get to area equals pi r squared. And so we're going to take whatever the radius is, which would be halfway across, half the diameter, and we're going to square it. And then we've got pi in there. We are mostly going to just leave pi alone and let it carry through our equations. Our final answers will have pi in it. So similar to the radicals that we've been studying, your final answer will have pi or have a radical. We're not going to go ahead and plug that in the calculator and get the nasty decimal and round it. We're going to leave pi alone, and that's called giving an exact answer. So you obviously will be able to use your notes, but the way that I always remember these, and it goes all the way back to my 7th or 8th grade math teacher, for this one, we had to memorize it. And the little saying that he used was cherry pie delicious. And not a great speller, that could be wrong there. And then for this one, apple pies are 2. So cherry pies, delicious, apple pies are 2. So C is your cherry, and then pie, and then the diameter D is delicious. Cherry pie is delicious, apple pies are 2. So I've always remembered that. You obviously can use your notes, but it gets a little faster if you can always remember which one of those is which. So if that helps you, use it. If not, that's fine too. All right, so we're going to find the circumference here. I'm going to use pi times diameter. In this case, the diameter is 10, so you always got to be careful. A lot of common mistakes is you just grab the number without making sure it is the diameter or the radius, whatever you need for that specific problem. So 5 is the radius. The diameter goes all the way across. The radius is the same in every direction. So this length is 5, this length is 5. The total diameter then is 10 all the way across. So this is going to be, to just drop this in, pi times 10. So again, we're not going to go ahead and plug that in and multiply. We're going to leave our answer just like that. But pi, just like a radical, just like an x, will be treated as a variable, and you want to put this coefficient up front. So I would like to see your final answer instead of pi 10 as 10 pi. Just like if it was 10 radical 2, we don't do the radical 2 and then the 10 after it. You put this number up front as the coefficient. So we can skip this middle step. I just dropped it in there so you could see how this lined up. But you can jump straight to this final answer. This is a good final answer. This is a great form that we can use. So if we take this circumference and then we start doing other things with it and we divide by something else that has pi, the pi just drops off and we have nice numbers. That's why we like to leave it like this, as opposed to getting the long decimal, rounding it, and now we're using a number that's not even the exact number. And the more you use a rounded number, the farther off you actually get from the exact answer. So We like to leave it like this. It's easier to work with. We don't have to deal with nasty decimals. So that's what we're going to do. All right, so here on the second one, circumference equals pi times diameter. Diameter is 20. We're just going to plug that right in. So I'm going to skip the middle step. I'm going to go ahead and put the 20 right up front. And there's pi. And that's my final answer. Nice and easy. Now remember, this is the circumference all the way around the circle. On the back, we're going to get to how do I find just a partial piece of that. All right, distance all the way around. Now we're going to do area. So area is obviously the inside. How much space is on the inside of this. So now we got to switch. Apple pies are 2. Area equals pi r squared. The radius is halfway across. When it's given to you like this, where the number is sitting right in the middle, that's the diameter. So this is 8 and 8, right? You divide 16 by 2. So the radius is 8. So area equals pi times 8 squared. So 8 times 8, 64. Final answer, you're going to put the 64 up front. 64 pi is a good final answer. So number 4, apple pies are 2. In this one, they gave me the radius. I don't have to do anything with that number. That's going to go right in. 5 squared is 25 pi. So if you were doing a problem maybe from the textbook and they want you to round your answer to the nearest tenth, we need to know where the pi is on the calculators. So the pi is right here in blue. So if I did want to get this answer in decimal form, I would do 25, and then here's my pi. So I would hit the second to get to the blue, and then this button. You can see the pi pops up. You hit equals. Remember that pi is actually equal to a number. 3.141592. I'm sure you've studied it before. It goes on forever. People like to memorize how far into the digits of pi they can go. So pi is actually a number. This is 25 times 3.14. That's why you can see 25 times 3. It gets you pretty close to this. But again, this is rounded off. Eventually, we're going to leave pi alone. But just in case you needed a decimal answer, that's how you would get it. All right, number 5. Find the radius of a circle whose circumference is 22 pi. So we are going to have to work backwards now. This is the answer, in a way, the circumference. How do we go back and figure out what the radius was? So circumference equals pi times diameter. This is the circumference. I'm going to go ahead and plug that in. The circumference is 22 pi. So I'm going to put that in for C, 22 pi. That equals pi times the diameter. So you can see how that lines up. 22 is the diameter. Algebraically, what you're actually going to want to do is divide by pi on both sides. We can always divide by the same number on both sides, multiply by the same number on both sides. It clears out pi. So diameter is left equals 22. And now they want the radius. Radius is always half the diameter, so the radius is 11. All right, and then what if they give you the area? So area equals pi r squared. They told you the area is 64 pi. So we're going to plug that in for area. 64 pi equals pi r squared. I see pi on both sides, so I can divide on both sides to clear pi out. Again, that's why we like to leave this. If we were go ahead and multiply 64 times pi and get the decimal, now this algebraically doesn't work out so nice. So leaving pi in it so that we can clear it out makes things much, much easier. Okay, so 64 is left over equals r squared. Be careful, that's not the radius, that's the radius squared. So some number times itself is 64. Remember, whenever we get to this point, we're going to take a square root, and now you might start to see, why is this in the same section? We were just doing radicals and triangles. Why are we doing circles? We're still talking about square roots. So you're square rooting that, and so your radius equals 8. The question asks for diameter. So if the radius is 8, the diameter is 16. Really easy on a quiz to get all the way to radius is 8 and never answer the question. So always go back and check and make sure that you've given the correct version, whatever they want, radius or diameter. All right, now to what should feel a little bit new. So we're going to compute arc length and the area of a sector, which is just a fancy way of saying a small portion of the circumference or a small portion of the area, not the full circle, but a piece of it. All right, so if you know the circumference and the degree measure of an arc, right? So this degree measure of an arc, remember, it's going to match the central angle. So if this angle is 90, the arc measure is also 90 degrees. So if we know that measure and we already know the circumference, so if we have the radius or diameter, we can figure out the circumference. We can calculate the length of just that little arc on the outside. So for instance, a 90-degree arc has a length equal to 90 out of 360, right? So your full circle is 360. This arc is 90. That's a fraction of the circle, right? It's a piece of the circle, a fraction of the circle. The fraction of the circle it takes up is 90 out of 360, which simplifies to 1/4. Really nice on these calculators. You can just go ahead and bring up your fraction, punch in those numbers, 90, 360, and then just hit equals, and it will simplify it for you. Now, obviously, when you were younger, you practiced simplifying fractions. You should be able to look at that and say, oh, I can divide that by 10, and then I can divide that by 9, and get all the way down to 1/4. But these calculators will handle it for you, as well as a scientific calculator. So if you were working with one of these calculators, you would hit the ABC button to create the fraction in the middle. So you actually hit 90 first. Then you hit the ABC button, 360, hit enter, and there's your 1/4 as well. So it will work on these calculators as well as these. All right, so once you've got that fraction of the circumference, you would just actually multiply it by the circumference, and then you end up with the length of just that arc. All right, that may sound confusing at first, but this is super simple. Once you start plugging it all in, you'll see. So if I want to find the length of an arc, I set up that fraction with the degree measurement over 360. Probably want to simplify it, and then I'm just timesing it by the circumference of the whole thing. You take the whole thing, you multiply it by that fraction, and it will give you just the length of that arc. Area of a sector is the same exact thing. You take the degree measurement over 360, and you just times it by the area of the whole circle, and it will give you just that fraction or just that sector. So when you see sector, it's just talking about a slice of the area. All right, so let's run through this real quick. Again, pretty straightforward. This should feel nice and easy, especially if you have a good calculator. All right, so we want to find the length of the arc. If this was a word problem, they'd say a person started here and walked around to here. It's a 90-degree angle, blah, blah, blah. So we're talking about this distance out here. So first thing you should do is try and find the circumference of the whole thing. What's the circumference all the way around? So 12 is the radius. Right, so that means there's another 12 on this side. The diameter is going to be 24, so circumference is 24 pi. And so if we're going to use this formula up here, right, if I want to find the length of an arc, I'm going to set up this fraction with the degree measurement out of 360, so 90 out of 360. You could leave it like that. You don't need to simplify. But we already showed it's 1/4, so I'll do it both ways just so you can see it. So it's 90 out of 360. That's the fraction of the circumference that we're looking at for this arc. You're going to times this by the full circumference. And what that does is just takes 1/4 of 24, or 90/360th of that, but it's the same thing. Those are equivalent fractions. So let's just say you were doing some just good mental math. You knew that 90 goes into 360 4 times. You can kind of visually see it, right? 90 breaks up 360 into fourths. And so you need to take 1/4 of 24, which you could just divide and get 6. 24 divided by 4 is 6. But you could also multiply by 1/4. It's the same thing. So if I punch this in, so let's say I started with the 90 over 360. Maybe I simplified it and I saw 1/4. And so 1/4 times, now don't punch in the pi. If you punch in the pi, it's going to go ahead and put that 3.14 decimal in there, and we don't want that. So just times the 24, and there's your 6, just like dividing by 4. So multiplying by 1/4 is the same as dividing by 4. And even if I used the other fraction, 90 over 360, didn't simplify it, if I times it by 24, it's still 6. So you actually don't, if you're using a calculator like this, you don't even necessarily have to do that extra little step of simplifying. But we will mostly still look at that because it's just easier to see, like, this is 1/4 of the circle as opposed to 90 out of 360. It's just going to make more sense if we use those simpler fractions. All right, so either way, we saw that this was 6, but it's not just 6, right? We still have this pi that's got to stay there. And so the length of this arc is 6 pi. And if it was a word problem and they wanted you to put that in more of a real world number, you would actually punch in pi and get the decimal and round it. So this should make sense. The whole thing's 24, right? So if I've split this into 4 pieces, this one's going to be 6 pi, this one's going to be 6 pi, this one's going to be 6 pi. They're all going to be equal. And so if I add those all up, I get the total of 24 pi. But the one we're looking for is right there. All right, so that was a little long-winded for a pretty easy problem. Let's go ahead and run this one. Obviously, we got to be careful. These questions look very similar. Area is talking about all of this section. The arc is just talking about the distance around the outside. So make sure you're using circumference or area, whichever one they're asking for. So here we're looking for the length of an arc. So we need to know that that's related to circumference. And diameter would be double the 18. So that would be 36 pi from 18 times 2, or 18 plus 18. 18 is the radius. Make sure you double it. All right, the fraction that we're looking at here is 240 out of 360. You, of course, could just leave it like that. But let's go ahead and see what that fraction looks like if we simplify. So 240 out of 360 is 2/3. And that makes a lot more sense. That's a lot easier to look at and visualize. So this represents 2/3 of the circle. And so we're just going to go ahead and take that 2/3 and we're going to times it by 36, and that's 24. So we're going to do 2/3 times 36 pi. In the calculator, we're not going to include pi. We're going to leave it alone, bring it to our final answer. So 2/3 of 36 pi is 24 pi. And again, you could have just used the fraction 240 over 360. You don't need the 2/3, but it's nice to know 2/3 as opposed to this number, which doesn't really look as useful for us. All right, and area is the same exact thing, except we're going to find the area first instead of the circumference. So the area of the whole thing, take the radius and square it. This is the radius, so 16 squared. 16 squared is 256. So the area of the whole circle is 256 pi. I've got this 90 out of 360. That's the fraction of the circle I'm looking at. We've already done that one. That's 1/4, right? It's cutting it into fourths. So you're going to do 1/4 times 256 pi, which is the same as dividing by 4. And that comes out to 64 pi. And then number 10. So we have a different angle. We haven't looked at this one yet. 45 out of 360. We go ahead and do that one. 45 over 360. That's 1/8. Okay, so this area is 1/8. So it's like if you cut a pizza into 8 equal slices. This is the one slice. The area of the whole circle, pi r squared. Again, they gave me the radius. I don't have to change that number. 9 squared. 9 squared is 81. So the area of the whole circle is 81. We want 1/8 of that. So if I did 81 divided by 8, I don't get a perfect number. I'm not going to take that decimal and put it in front of pi. It's technically correct, but when we leave these as exact answers, we're not going to put a decimal in front of pi. Otherwise, we might as well just multiply by pi and just have a big decimal and round it. So we're going to leave things as a fraction. So if I'm multiplying 81 pi times 1/8, since this isn't going to work out super nice, I can go ahead and put this over 1, multiply straight across. I get 81 pi over 8. And we're going to take a look in the calculator to see what that looks like. But that can't be simplified, and that is the final answer. So I wanted you to see one where you can have a fraction. We're going to leave pi in there. All right, 81 over 8 does not simplify nicely. We already showed that it gives a decimal answer, not a whole number. If I could divide this, like if this was a 9, 81 divided by 9, then I would just get 9 pi, and I would go ahead and do that. But if I just punch in 81 over 8, as a fraction. Notice that it doesn't simplify any more than that. So I'm just going to leave it like that. Keep pi up in the top. You could technically put it next to it. You could do 81 over 8 pi like that. That says the same thing. Those are equal. But the form that you're going to see on an answer key or something like that, you're going to see pi up there in the numerator of the fraction.